All right, let's jump right in. You know that iconic image, right? December 17th, 1903, Kitty Hawk, North Carolina. This fragile-looking machine made of wood and cloth lifts off the sand. But what was really proven in that moment? I mean, what scientific code was packed into the 12 seconds that came next?
12. That's the number everyone remembers. The first flight lasted just 12 seconds. It covered a grand total of 120 feet. I mean, that sounds almost kind of pathetic, doesn't it? You can't even cross half a football field in that distance.
But here's the thing. Those weren't just any 12 seconds. They were incredibly dense. They were the grand finale of a decade of obsessive work, of systematically reinventing not one, but three separate fields of science. It was like an entire revolution in thinking, all squeezed into the length of a TV commercial.
And that gets us to a really fascinating idea. We usually think of that short flight as, a humble beginning, a limitation they had to overcome. But what if we've been looking at it all wrong? What if those 12 seconds were exactly as long as they needed to be to prove everything that actually mattered?
To really get why, you have to kind of zoom out and remember what was going on at the time. In the early 1900s, powered flight was the great unsolved problem. It was this huge dream, sure, but it was also littered with the spectacular, very public failures of the world's smartest people. And this is where the story just gets incredible. I mean, look at the contrast. You had Samuel Langley, a big shot at the Smithsonian, with a massive government budget and a dream team of scientists. And what happened? His machine plunged straight into the Potomac River. Not once, but twice. The press called it Langley's folly. Then, you have two brothers funding their obsession with the profits from a bicycle shop in Dayton, Ohio. The results? Well, they speak for themselves.
So, how on earth did they pull it off? It wasn't just luck. The Wrights won because they were methodical. They identified and then solved three totally separate, huge problems that had stumped literally everyone else. Let's break them down.
So here's the roadmap. First, they had to pretty much reinvent the wing from scratch by creating their own aerodynamic data. Second, they had to master control, which meant solving the fundamental problem of how to balance an airplane in the air. And third, they had to build an engine that was both light and powerful, an engine that just didn't exist yet.
Okay, so problem number one. Every top scientist back then was using the same official, published charts for how much lift a wing could generate. But the Wrights, after their early gliders kept failing, they had this terrifying realization. The data was wrong. All of it. The very foundation everyone was building on was completely flawed.
So what do? They go back to square one. In the back of their bike shop, they build this little wind tunnel and just start testing. They methodically tested over 200 different wing shapes. 200. Can you imagine the patience?
And this right here just shows their genius. I mean, their wind tunnel was a marvel of DIY engineering, built from scrap metal and bicycle parts, but the data it produced, it was revolutionary. It completely demolished the accepted science and proved that long, thin, gently curved wings were way more efficient. And here's the brilliant part. They didn't tell anyone. They kept it all to themselves and just started building better wings.
Now for their second big breakthrough, and honestly, this is probably the most important one. See, everyone else was trying to build a perfectly stable airplane, something that would just fly straight on its own. The Wrights, though, they spent hours watching birds, and they had this radical insight. The secret wasn't making something stable. It was making something you could control.
This is so crucial. They literally invented the entire concept of three-axis control. The idea that a pilot has to actively manage the plane's pitch, yaw, and roll. This concept that they figured out, it's still the absolute foundation of every single aircraft flying today.
And here's how their amazing system worked. A forward elevator controlled the pitch. That's the nose going up or down. A rear rudder handled the yaw, the nose turning left or right. And for roll, the tilting of the wings, they invented something incredible called wing warping. They literally twisted the wings using cables that were connected to a cradle the pilot shifted with his hips. The whole thing was one complete integrated system.
Okay, so they've got the perfect wing shape and this revolutionary control system, but they still need an engine. And here's the snag. Back in 1902, there wasn't a single engine in the world that was both powerful enough to create flight and light enough to be lifted off the ground. They wrote to all the big car companies, and every single one said, nope, can't be done. So, they just built one themselves. Their amazing shop mechanic, a guy named Charlie Taylor, he carved a custom 12-horsepower aluminum engine out of a solid block of metal in just 6 weeks. Now, by today's standards, that engine was pretty weak. But it was light, and it was just powerful enough to prove their theory.
Which brings us right back to that cold, windy morning at Kitty Hawk. You have to understand, this was not some calm, sterile experiment. This was it. This was the tense, dramatic finale of years of work, of risking absolutely everything on this one fragile machine.
So just try to picture the scene. The Flyer wasn't some shiny new invention. It was this delicate thing made of wood and fabric, and was already battered and patched up from earlier crashes and weeks of bad weather. Everything was riding on this one single attempt into a freezing headwind.
And when it finally lifted off, it wasn't graceful. It was a fight. The machine bucked and swayed. The left wing dipped down. Orville overcorrected them. The right wing dropped. He was actively, physically wrestling with this unstable machine for every single second he was in the air. But that wrestling, that constant correction, that was the whole point. He was demonstrating active three-axis control, live, in real time.
So what is the true legacy of that brief, wobbly flight? It's not about the distance or the time. It's about the fact that in those 12 seconds, the Wright brothers wrote the fundamental grammar of flight. They created the rule book. And you know what's just wild? Almost nobody noticed. Their own hometown paper, the Dayton Journal, buried the story and got most of the facts wrong. A world-changing event happened, and it was met with, basically, silence. It took years for people to really get what had happened that day.
But just look at the explosion of progress their breakthrough unlocked. You go from that 12-second flight in 1903 to a human being walking on the surface of the moon just 66 years later. An entire species-altering revolution, all within a single human lifetime. And it's all built on the logic they invented at Kitty Hawk.
So let's bring it all back to that main idea. The flight's success isn't measured in feet or seconds. It's measured in the density of the breakthrough. In that one single fleeting moment, they proved their unique solutions to aerodynamics, to control, and to propulsion all at once.
And this really is the key takeaway. Those 12 seconds, they overturned centuries of wrong ideas. They solved the three-part puzzle that had beaten the greatest minds on the planet. And they laid down the fundamental control logic that every single aircraft, from a 747 to a stealth fighter, still uses to this very day.
Which really just leaves us with this final thought. For centuries, everybody was obsessed with the first part of that question, just getting a machine into the air. The absolute genius of the Wright brothers was realizing that the second part, controlling it once you're up there, was the only thing that truly mattered.